Hey guys, welcome back to our channel. In this video, we'll be solving this puzzle called linear algebra, which is in a NumPy section. Let's go through this. The NumPy module also comes with a number of built-in routines for linear algebra calculations. These can be found in submodule linear algebra. That means, okay. So first is the linear linalg dot det, which will calculate the determinant. You can see, you can go through the details. Here you can see, this is how you write the determinant: numpy dot linalg dot det, and here inside you provide the whatever array you want to compute the determinant. So the linear linalg dot det tool computes the determinant of an array. So this is your array, and this is how you define the determinant in NumPy. Similarly, you have linalg dot eig, which will compute the eigenvalue and write eigenvectors of a square array. Here you can see, if you will calculate the linalg dot eig for this array, this one, you will get eigenvalues and eigenvectors, and you can print them separately, vals and vex. Here you can see these are the eigenvalues and these are the eigenvectors. Similarly, you have linalg dot inv, which will calculate the multiplicative inverse of a matrix, and this is your matrix, and if you'll do it, you'll get the inverse of the matrix. Other routines also you can find. So basically they are telling you that you can, with the help of NumPy module, you can also do linear algebra calculations. Some of the calculations they have showed. What is our task? You are given a square matrix A with a dimension n cross n. Your task is to find the determinant. Note, round the answer to 2 places after the decimal. So this is the note point. The first line will have the value of n for this n cross n, and then the next n lines contains the n separated elements of an array. Print the determinant of A. So here you can see 2, so it is 2 cross 2, 1.1, 1.1, and the determinant is 0. So let's take the input first. Input n I'll take for dimension, int input, then you have the array we have to take. Same thing what we have done before. For I in range 0 to n, 0 to n, and inside this it will take a dot append, then list map not int float, because we have float values here. You can see float comma input split. So this is how it will take the input. Now let me convert into a NumPy array. NumPy dot array, and write A here. Now we have our array, so we just have to calculate the determinant now. This is it. So let me copy this. Here you have print. Okay, so we have to do some round off thing also. So let me save it into a variable called det, and this is correct. Here you will write a. Now that is correct. Now we have to print round off to round det to 2 decimal places. So I think this is done. Let's see. Yeah, sample test case pass, rest all the test cases are also passed. So it's a simple exercise comparatively, and we have completed all the numpy challenges. Let's see our other routines, what else it provides. Pi dot L, matrix, inner outer, tensor dot product, cron, these Chokolowski, QR, SVD. These are the methods of decomposing an matrix in linear algebra, calculating eigenvalues, eigen vectors, then norm also you can calculate. Basically you can do a lot of things which is there in linear algebra. Trace also you can find. So just a glimpse of it. With numpy tool you can do linear algebra calculations. So let's move to the next module now.